Good evening, all. Dikshita, ma'am.
Yes, ma'am. Good evening.
Ma'am, we can wait for 5 minutes, ma'am.
Mm,
As the
yeah.
participants are joining, we'll start in 5 minutes, ma'am. 6 5.
Okay. Yeah, sure,
Yeah,
ma'am.
okay, okay. Yeah, thank you.
Yeah. Thank you.
Indian gas na ingulladana anga
Good evening, everyone. I welcome you all for the fifth day of our industry oriented FDP on the power of AI in industry, automating AI development, and ensuring its practices. In this session, I would like to welcome today's resource
Ma'am,
person.
your mic gone.
Let's start again, sir.
Yes, ma'am.
Good evening, all. I welcome you all for the fifth day of our industry-oriented FDP on the power of AI in industry, automating AI development and ensuring its practices. In this occasion, I would like to welcome today's resource person, Ms. Dikshita, Data Engineer, IBM, Bangalore, India. We welcome you, ma'am. Uh, we are looking forward for your session on the topic generative AI. I would I would like to say that the participants of today's session will gain some knowledge out of this session about generative AI. And a request to our participants, please mute yourself during the entire session, and at the end of the session you can unmute, or in the chat you can post your queries. And again, at the end of the session, the feedback link will be shared. Now I would request Dr. Vamsi sir to introduce our resource person, Ms. Dikshita. Sir, please, sir.
Thank you, Dr. Jennifer, ma'am. Good evening to all the participants. We are delighted to welcome Ms. Dikshita K, a data engineer at IBM Bangalore, as today's esteemed speaker. With over 3 years of experience in data engineering, she has specialized in designing and maintaining scalable data pipelines, ETL processes, and big data storage solutions while optimizing system performance for high impact business insights. At IBM, she has worked extensively with Apache Spark, Kafka, Airflow, and PySpark, developing robust data architectures to support diverse data sources. She has played a key role in automating business reporting, implementing proactive production alerting systems, and enhancing data security through AI-driven solutions. Additionally, she is well versed in containerization and cloud computing, leveraging platforms such as IBM Cloud and AWS for seamless scalability. Beyond her technical expertise, Ms. Dikshita K is an award-winning problem solver. She was the finalist in the Smart India Hackathon in the year 2020. Her academic and research contributions include patent disclosure on data and generative AI, innovative R&D in explainable AI with IBM Watson AI, and actively participation in the IBM Developer Jumpstart program. With expertise spanning machine learning, AI ethics, big data, and cloud automation, MAM is at the forefront of AI-driven data engineering. Today, she will share her insights on generative AI, exploring its transformative impact in the industry. Let us a warm welcome to Ms. Dikshita K. Now, without further delay, I hand over the session to you, ma'am. Over to you.
Thank you so much, Jennifer, ma'am, and Vamsi, sir, for the brief introduction. Yeah, good evening, all. Hope everyone is doing good. Uh, so, I'm very happy for joining today's session on generative AI, and I'm really excited to share my insights on this fascinating topic with you guys. Okay. Um, so let me share the PPT. So, could you please let me know if it is sharing?
Yes, visible,
Uh,
ma'am. Yes.
Thank you, sir. Okay. So, why generative AI? Why do you think it is important? Uh, so basically, um, these days, if we see, generative AI is most exciting technologies today. It is writing text, it is creating images, it is creating musics, it is composing musics. Uh, so that's why we need to know what exactly it is. So but how does it actually work? So if we need to use the generative AI in our daily life, we need to know uh, what exactly it is so that we can use it effectively. And then that is what we'll be exploring today during this session. So before I go ahead, I would like to check on the audience here. Have you ever used ChatGPT or Midjourney or Dolly, which creates images, or any AI tool? Can I get some yes, no in the chat box? So, do we have chat access for the students?
Yes, ma'am. We are having. There
Okay,
is an option called chart
okay, yeah, okay.
beside to take control. Yes, yes. Or if you want to read me any questions, na I can read for you.
Okay, yeah. Uh, so yeah, students, I wanted to have an interactive session. So can you please let me know if you have any experience? Okay. So most of you have Ravi, Bhavya. Good, good. Yeah. So we have people already having used the AI tool. So okay, let's see. Let's go ahead. So before getting into generative AI, let's come back one step. Okay. So before we get into generative AI, what is artificial intelligence? AI. Let's understand what is AI. So AI refers to the simulation of human intelligence, which will actually enable the models or devices to think like humans, mimic human tasks, analyze data, make decisions instead of human beings, and also like recognize the speeches or pattern detection. So all these can be done using artificial intelligence. So what are the main capabilities of AI? The main capabilities would be coming up with problem solving, decision making, and pattern recognition. So these are the three main capabilities that we achieve through AI. So AI algorithms can analyze complex data sets and derive insights from those. So once they derive these insights, they will be ready to make the decisions. Okay, the AI models will evaluate different scenarios and suggest the best optimal solution. So when you're some confused, which decision to take, AI helps you make your decision easier. And then when it comes to pattern recognition, so we are actually in artificial intelligence, uh, AI will try to detect patterns with what all data you feed it. So when it tries to identify frauds or medical diagnosis, where it will try to identify a particular disease or something of such sort, so it will try to recognize patterns among the data that it has. So when we come to AI, we have two types of AI. One is narrow AI and the other is general AI. So we are not yet there to general AI, where general AI is like it refers to like advanced data systems, AI systems, where it has complete data and then it will be able to think like humans without anything. You need not have an human being sitting and training the data model or something. So it will be like human, like mimicking, you are creating another human being. So its capabilities will be learned without any task specific training, exhibit common sense. It will be emotionally intelligent, basically. So basically, you can think of this uh, robo movie wherein it will actually do everything like a human being. It will think on its own. It will do everything on its own. So in the similar way, so we are not yet there. So scientists are still working on bringing us to that stage, the AI models. So they are so this will be the future of AI. So it requires self-awareness, reasoning, and then general learning capabilities. So today's AI, what we use is the narrow AI. Basically, it is not very strong as general AI, but then it is weak AI that we use. But then, why we say weak AI? Because it needs some human assistance. We need to train it. It cannot think on its own. It cannot reason on its own. Uh, and also, it cannot apply knowledge beyond its things. Because when we say we are actually trying to create a model of text generation, if you say, so that can only generate text. It cannot generate videos or images. So that is what when we say, so there are models which will do text generation, video generation. So that is a multi-model AI. Okay, so we do have limitations with narrow AI. So it cannot think on its own like human being does. Uh, like in an untrained situation, so you're not trained how to create videos, the model is not trained, so it will not be able to do that. So it requires extensive data and then also fine tuning. So it has large amount data, so it needs fine tuning for different applications when it comes to a specific use cases, the medical use cases. If it is into the medical industry, it needs a very specific use cases where it needs to train on the medical data specifically. So if you bring a data which is irrelevant, it would not help the model to generate the responses for the user. So examples of this narrow AI are voice assistant like Siri, Google Assistant, Alexa. We also have chatbots like ChatGPT, Bard, customer service bots. Like when we log into some websites, we see these pop-ups coming, chatbots coming up, right? So these are all built on the narrow AI. So we also have these recommendation systems like Netflix, YouTube. Now we do have recommendation systems everywhere. So people are training the models, and then it is actually transforming the businesses to be more specific. And then it also has this computer vision, where face recognition, and then medical imaging analysis, where it is trying to analyze the medical reports and trying to identify the diseases. And also facial recognition, where you don't need to have people sitting there identifying, validating the data. Okay, so these are some insights into the narrow AI and general AI that we have. Going ahead, machine learning is actually sub part of deep artificial intelligence. So machine learning is actually the foundation of AI, we can tell, where machine learning is a subset of AI that enables computers like to learn and then make predictions. What kind of predictions? If we try to give the data of a particular business, how it is working. So the machine learning model help us how to predict the next year sales or next year profits of that particular company. So based upon the previous data that we have. So without we are not actually explicitly programming anything there, but then it tries to learn from the data that it has and try to make predictions. So ML models improve their performance based on experience rather than uh, relying on predefined rules. Basically, when we try to write code, we try to give some conditions. So if this particular condition is satisfied, this should be the output. If this is the case, this is. So when it comes to large data, it actually narrows down. It becomes for the developer to try to bring up many use cases, many conditions to end up there. So that's why we use these machine learning models. And then here in machine learning, we use supervised learning, where the model learns from labeled data. Example like spam detection, like emails. We will try to tag it, like the emails which are spam are tagged spam, so they are labeled such way. And then unsupervised learning, where the model finds to understand and try to bring patterns from the unlabeled data. Okay, so it is not labeled, it is spam or not something. So it is generic, like customer segmentations. So there are different customers, and then you're trying to segment it. So then we use unsupervised learning. And then we also have in machine learning this reinforcement learning, where the model will actually learn through rewards and penalties. Okay, so when actually it predicts correctly, it will get a reward, so that it will actually understand, okay, this is a correct move. And then sometimes it will be uh, having penalty, which it will understand, okay, this is a wrong one, so this needs to be corrected. So the common applications of ML are fraud detection, predictive analysis, speech recognition. Okay, and then diving deeper, we go there till deep learning algorithms. Okay, so basically, deep learning is the power behind AI. Okay, so so machine learnings can actually handle to some extent. So when the data is becoming larger, and then it becomes difficult to handle those. So it needs a larger models with neural networks, basically. So it is a advanced type of machine learning that will actually uses neural networks. So neural networks is like a human brain where neurons are there. And then so to process large amounts of complex data, and then uh, recognize patterns from those data, uh, we actually use the deep learning concept. Um, Here, the deep learning, the neural networks, actually, it is actually inspired from human brain. And then deep learning models can actually recognize patterns in the text format or speeches or images. Um, and then how does this actually work? It uses artificial neural networks, and it also extract features automatically. Unlike in ML, we actually need to do the feature selection in machine learning. But then here in deep learning, we don't need to do that. And then to work with deep learning models, we actually need large data sets and high computational power. We need GPUs, TPUs to work with it. Okay. So where are we actually using this deep learning? If you ask, we are actually using for natural language processing, where we have conversations with the chat GPTs or Google Assistants, Google Translate, and then also for face recognition, and then for autonomous systems like self-driving cars, robotics. So these all use the deep learning concept. So now we know what artificial intelligence, AI, the basics of it. So now let's get into our main topic, generative AI. So what do you think generative AI would be? So the name itself says it is generating something, right? So basically, generative AI is a type of artificial intelligence that can create new content. It could be text, images, music, videos, and codes. So now nowadays, like Nvidia has recently announced that we don't need to learn data structures and algorithms. Developers actually we can replace developers. How is that? How is that they're gonna achieve it? So basically, they are trying to use Gen AI try to generate code basically. So instead of sitting and writing the code for hours and hours, they are trying to generate the code based upon their requirement. It is not just that. So in recent times, you might have seen the deep fake videos where the videos, the faces are actually mimicking of celebrities. Basically, it is not the real video, but then they're trying to use this Gen AI and create those videos. It's not there, just there. So we can generate text like email. So if you need to write an email, you can just ask the Gen AI um, to actually give an input. So write an email to the professor. You can just give that, and then it will give you an email format. And then if you are actually trying to imagine something and you wanted to create an image, then you can actually what you can do is you can ask the AI model to create an image. So I'm actually imagining, can you create an image of a forest with waterfalls? So it would create with your specifications. Okay. So these actually are done by learning patterns from large data sets, basically. So we need ample amount of data. Uh, Unlike the traditional AI and all, which primarily analyzes data and makes predictions. So it is just there at predictions. But then generative AI will actually create content uh, like humans do. Okay, like we when for example, a author is there or a poet is there. A poet will write a poem based on his thoughts, his surroundings and all. An author uh, tries to create a plot. He's actually creating some content. So similarly, the Gen AI also resembles this human created work. It tries to generate from the data that it has. Okay, so the key characteristics of generative AI is content creation, pattern learning, creative assistance, and conversational understanding. Basically, if you take this content creation, so we have this chat GPT for creating text, and then we have doll E, which actually helps in creating images. This is both ChatGPT and DALL-E are from OpenAI. So OpenAI has developed these Gen AI tools. Then coming to pattern learning, it learns from vast amounts of data. So this will actually create meaningful outputs. Apart from this, we have creative assistance. So when you need an assistance in writing some content, so you're actually trying to uh, do some presentation. You wanted to know how to present it, what to cover, what all to cover. So you will ask the AI tool for the amount for writing the content or correct your email. So you're writing an email, you wanted to know if it is correct, grammatically correct. So it will actually help you in writing that. Or even nowadays in code, right? So you will be able to even write, generate code based upon your requirement. And then conversational understanding. This is actually the key characteristics of generative AI, because it needs to understand the conversation of the human being. So only then it cannot just vaguely give answers for whatever inputs that you're giving. You're asking for some email, and then it cannot just you're if you're asking an email for writing it to a manager, it should be formal, right? So it needs to understand what is the context and what is the situation it needs. So it should be like if you're it will actually be like you're speaking to another human being, basically. This conversational understanding will actually power chatbots like ChatGPT, Google Gemini to actually achieve better outputs for the users. Okay, and then going ahead, we'll see the difference between the traditional AI and generative AI. So when it comes to traditional AI, the focus area is analyzing data and making predictions. When it comes to generative AI, the main focus is around creating new content. Okay, so here the content plays vital role. And then when it comes to traditional AI, the examples would be sample detection, and then the fraud detection, right? Um, Here, generative AI, we do, as already said, ChatGPT and DALL-E are some examples of generative AI. Here, in traditional AI, what we do is we actually use supervised and unsupervised learning, reinforcement learning. But then when it comes to generative AI, it is self-supervised, uh, and also fine-tuned. So basically, if you have observed, in some cases when you are using ChatGPT, when you write some query or something you're writing, and then it says memory updated. So it is actually trying to improve its own model, trying to update its data, and trying to improve, fine-tune its thing. So it is self-supervised and also fine-tuned. Okay, and then let's see how this generative AI works. So basically, okay, um, seeing how the generative AI works, the neural networks and the deep learning here plays a vital role. Uh, Basically, generative AI models are built using the deep learning techniques, especially the neural networks here actually help us the most. So, the key steps in generative AI are training on massive data sets. It should be very large scale. It uses large LLMs, basically, large language models in it. Okay, and then it also uses neural networks um, to leverage this advanced neural network architecture. So we have different neural network architectures that we'll be seeing furthermore, and then also generating new content. So these are the key steps of this generative AI working. So when a new content is created, how does it create? It depends upon the input, the prompt that we give. So what are we expecting? Uh, so it depends on that. Okay. It predicts if at all we give a incomplete sentence. Okay. It try to complete it based upon the previous data, the previous whatever we have given. So whatever input we have given. So we have given an incomplete sentence. It will try to understand, oh, okay, the user has given this one, so we need to complete the sentence. How do we complete it? Grammatically sees what needs to be done. Um, or else you can ask for it to tell a story, right? So it will try to generate a unique story that you haven't heard. So this is all about how the generative AI works. So when we deep diver into these, so neural networks actually rely mostly on vast amounts of data. Okay, so we need to process this, and why is this important? These heavy neural networks actually help us generate human like output. So we need, it is not AI generated, like we need to mimic the humans, right? So neural networks plays vital role here. So a neural network is like a computing system inspired by human brain, as we already discussed. Why are we saying that? So in this neural network as well, we do have something called neurons, which will actually store the data. So why are we saying human brains? It's trying to identify the patterns. Basically, take a scenario where a person tells, um, a person named Ravi Kumar is there, and then he tells, "Hey, this so and so person has gone for higher studies this year after his bachelor's degree." And then a person beside him would tell, it is so obvious that he has gone because all his cousins has done masters and they have gone after immediately after bachelor's. So this conversation between these two people, if you see, actually the other person is trying to make a pattern. He is trying to identify a pattern where, sorry, okay, so where he is thinking, okay, all his cousins already went for masters, so it is obvious that he would also go. So it is the human brain that it is actually trying to identify pattern from the situation that has happened. So in the similar way, the neural networks also try to create patterns. Okay, so this data is there. This is how. Uh, okay, which category of people are purchasing this particular product? So it will try to identify multiple patterns. So which age group, which occupation, at which time, even the season matters, everything. So things like that. So what is this? For this neural network, we have input layer, hidden layer, and then output layer. So the input layer that takes the raw data, and then the hidden layers actually process input um, data and then do the mathematical computations to bring the patterns. So the output layer will actually do the final prediction and generate content. Okay. Here each neuron is connected by weight. Okay. The network learns by adjusting these weights based upon the errors, the back propagation, if you see. And then coming to deep learning. So deep learning is subset of machine learning that uses deep neural networks. Okay. How does deep learning work? So it learns features automatically, unlike traditional machine learning. It uses large data sets, like more data improves the learning and accuracy. So if you have just let a bit of data and then which will not actually give the all scenarios, it will not be very accurate, the prediction. So when it has large amount of data, it will be able to have more accuracy and more precise solutions. So and it is also computationally intensive, so it requires high powered GPUs. And then coming to the architecture of generative AI, so we have key model architectures in generative AI. That is transformers. Basically, transformers are the backbone for modern AI. Here, it actually is a state of art, you can tell, for the natural language processing models, NLP models like GPT, BERT, and all. So what is GPT? GPT is generative pre-trained transformer. Okay, this is developed by OpenAI, and this is unidirectional model. So it is actually used to predict the text that would be coming afterwards. We would give a half sentence, and it will try to predict the continuation. Okay, so this here it actually processes the text from left to right and then predicts the next word based on the prior words. And then it is actually used for text generation, and then chatbots or any creative writing you wanted to do. So here the training approach is pre-training and fine-tuning. So it is actually trained on vast amounts of text data, and then it is actually optimized on specific tasks, uh, conversation tasks or summarization. It will try to fine-tune. For example, you can actually give a sentence, once upon a time there lived a king, and then it will try to continue the sentence, that output. And then the other example for transformer is BERT. BERT is bidirectional encoder representation from transformers. Okay, so it is actually when it comes to GPT, it is actually unidirectional. Okay, but then BERT is bidirectional. It previously it was actually trying to understand the data right from left to right, but then here it will try to understand from both the ways. From it will try to read full context, from left to right to left. Okay, so this is actually BERT is developed by Google and then optimized for understanding rather than generating text. It is more of understanding the context or the usage there. Okay. And then to give an example, when I say the bank was on the river bank, here, when I started it as the bank, it can be referred to as the bank where we deposit amounts, right? But then here the context is the river bank. So here it tries to understand, okay, bank means river bank. It is not the bank where we try to deposit amount or something. Okay. So BERT is actually more for understanding the textual data, whereas GPT is for generating the text. Okay. And then coming to the next one is diffusion models. So these diffusion models are actually AI models which actually help in generating images. Okay, they work by starting with random noise and then refine step by step until they get a concrete image. Okay, so how does these diffusion models work? So I've given a image here where it actually tries to uh, add noise, actually noise, and then try to get an image. So basically how does this diffusion model work is first it will noise addition and then reverse process and then final output. So initially it will try to add noise to the images during training, so to correct them. Okay, and then reverse process during the generation, the model will try to remove the noise gradually and reconstruct new image. So the final quality of this particular input would be a high quality AI generated image. Uh, what would be expected from this diffusion model? So if you see a GIF is there, so just for understanding thing. So we also have an examples like we can use DAL-E, which is actually developed by OpenAI, and then Imagen by Google, and then Stable Diffusion is another tool by Stability AI. So DALL-E actually generates images from text prompts. If you give a particular text, it will try to generate an image from whatever text you have provided. And this Stable Diffusion is actually open source alternative for custom art generation. For any art you wanted to create, something of such sort, you'll be using that. So yeah, and then going to the next model architecture is GANs. Okay, generative uh, adversarial networks. So here GANs, when you see GANs, you can see the architecture here. Okay, we have this generator network and the discriminator. Basically, the generator actually has the fake data, and then the other side the real data. So what actually is this architecture doing? So GAN is another major approach for generating uh, AI content. Here, we will be using two competing networks, basically the generator and the discriminator. So here the generator tries to create realistic content, like example the images actually, and then the discriminator, what it tries to do is it tries to detect the content and then say whether it is real or fake. Okay, so this is what it happens. So they keep improving by competing against each other. Okay, so they try to compete with each other and make a final output that is highly realistic, basically. And then we have different applications of GAN, uh, where we see very commonly nowadays the deep fake videos. Okay, the generalistic human faces and videos that are being circulated around, right? You don't know whether it is coming directly from the person or it is being made up. So and also nowadays people are using the Gen AI for generating art. So the Gen AI is so nice that it is actually creating arts and portraits using deep art. Okay, deep art AI generated paintings, which is actually selling for a lot of money, a lot of dollars there. And then we have synthetic data, like creating fake but useful training data. So for training the AI models, basically we are trying to create synthetic data that doesn't exist, like that didn't exist, but then we are trying to create it, uh, and trying to train our models based upon that. Okay, and then coming to model training and fine tuning. So AI models are not just built, they go through intensive training, which will actually improve the performance. So why is this so important? This is actually needs to be done on massive data, for accurate data. So massive data collection actually helps AI being trained on billions of data, so that it tries to get each and every use case, each and every case that could be a possible outcome. Okay, and then it during this model training we also do pattern learning. Okay, so the neural networks try to detect the structures, the relationship between the data. So whatever data we are trying to use, it will also try to uh, have this neural networks detect the patterns in the data. Okay, and then weight adjustment. So AI continuously updates its internal parameters to improve the accuracy. So if some parameters are not required, it will try to improve its accuracy by adjusting the weights on the data that it has. And then fine tuning. Okay, what is fine tuning? Like pre-trained models are like optimized for specific tasks. Okay, some conversation for a particular, when you say for a particular context, medical context or some other context, it needs to be fine tuned with respect to that particular domain or that particular area to be more accurate. Okay, so why fine tuning matters, if you ask, models provide relevant data, and then relevant responses for the specific use cases, rather than being vague. So, in the previous example, we have seen the word bank being used in a different case, like the river bank. So, when it tries to understand the context, it will be more, it would actually give more relevant answers for the inputs that we have. So, example, ChatGPT 4 can be fine-tuned for medical Q&A or the customer service chatbots and all. Okay, so we can embed those. So what would be the future model architectures? So the future model architectures would be larger, more powerful models than that we have now. Okay, and then efficient AI with fewer resources, basically. So that now the Gen AI is actually on like systems. We have chat gpt and all. So in future it would be like for mobile use as well, smaller models where we can easily use lightweight models. And then explainability, or and then fairness in these models. Basically, uh, these days the generative AI models are like more like black box. You give some input and you get the output. So internally what's happening, you don't exactly know. So the future AI model architectures will be like that have better explainability and more fair answers. Okay, so it will not have any bias. Okay, so this is how the generative AI works. And then we'll go next, the key components of generative AI. Okay, so coming to the key components, uh, as I said, the generative AI models are built over LLMs. Okay, large language models. So whenever the Gen AI comes, it LLMs are in place. So they come easily into the picture, because without LLMs there are no Gen AI tools. So LLMs are actually advanced AI models which are actually trained on large text, okay, vast amount of text, understanding the generate human language, trying to generate human language what they are doing. And then they use deep learning techniques, particularly the transformer architecture. So the image here is actually the transformer architecture which is used by LLMs for predicting the text sequences and all. So if you see the key features of LLM, the large language models, one is scaling. Scaling, it means it is trained on high amount, high volumes of data for accuracy and context understanding, so that it can actually generate data on relevant context. If you're asking about a particular context and then it tries to give a different context, it is not useful, right? So context understanding is one of the feature of LLM. And then multimodal capabilities. So basically, what are these multimodal capabilities is like, if you take an example of a Gen AI, if it is actually able to support multiple models, like it is able to handle text, images, videos, audios. So it is actually called multimodal capability. Okay. So which is actually able to handle different data. And then we have self-supervised learning, like learn from the patterns in the data without explicit labels, like without a human trying to tell this is and so. So with whatever data it has, it will try to learn from its own patterns. Okay. And then um, this is this is one of the key component of Gen AI. And then we also have the important components, training data and parameters. Okay. So when it comes to training data, AI models, especially generative AI models like GPT, require vast amounts of data. So where is this data coming from? So we need to take this data from um diverse sources. Basically, if you are just taking it from one particular source or one particular location, you are actually trying to create bias wherein you don't know what exactly is it learning. So you're actually being specific to that particular region or specific thing. So we actually need to use vast sources like books actually. So when it comes to books, it will actually help the model to learn structured writing, grammar, storytelling and all. And then we also need to train the model over articles, research papers, web pages, forms, code repositories, basically for code generations. When the model is actually used for code generations, then we need to also use the code repositories, images, videos, and audio files. So this is a whole sum of different diversified data that we need to use for training our models for more accurate data and more relevant. And then the role of parameters in AI models is actually important. Why is it important? Because these AI models have billions of parameters. Okay, when it comes to AI models, parameters actually act as the memory units that store knowledge actually for the training data, wherein the neural network weights and biases. These parameters will actually adjust the AI interpretation and the relationship between the data that we have provided. And then the transformer based models like GPT and all, these will have different parameters, like a lot of parameters, so that it will be able to analyze the context, predict the text pattern based upon the particular pattern. So by this way we can understand that parameters act as a crucial role because they store the knowledge, right, on what the data is being provided. And then coming to tokenizing and embedding. So here, uh, tokenizing is nothing but when you give a text data, a particular text data is broken down into smaller parts. Okay, so this process of actually breaking down the text is called tokenization. So before AI models process text, they must actually break it down into smaller parts known as tokens. So this tokenization will actually help AI understand the text in manageable pieces instead of actually trying to take the whole whole big sentence and trying to understand it. So it will make it easier. And then token after a tokenization, embedding. So what is embedding? Embedding is actually where the AI model will actually try to assign a numerical vector for the words. Okay, so which will be unique. So what will this happen? So it will be actually easy for the AI. Okay, so this is for AI models to understand the context. Okay, um, because numerical data is like the mathematical representation, which will help the AI understand the context. So this will actually uh, help in creating meanings, relationships. It will try to identify. So the AI models will try to identify the relationship between the words and all. So for example, uh, there is a word king and queen. So when it comes to embedding, the embeddings of these two words will be numerically close because they are somehow related in the meanings, right? In English text, we know, okay, king and queen, so they are related. But then how does AI know that? So in by this numerical representation, it will try to have close numerical values. By this, it will try to identify, okay, these are related. Okay, so this is the importance of tokenization and embeddings. Coming to inference and output generation, so once the AI model is trained, okay, it actually enters the inference phase, okay, where it can generate content based upon the prompts. So, predicting the next word or image in a pixel. It can also be the probability based upon the selection. So AI tries to assign the probability of different possible outputs, and then it will try to pick the most probable, the word or something that has highest probability. So this is how the inference phase works. And then, um, for example, uh, we have this prompt saying, "The sun rises in thee." Um, it can be east, it can be morning, it can be sky, right? In the sky. So basically, it tries to put in probabilities, multiple probabilities, and it will try to understand, okay, the most common phrase that is being used is the sun rises in the east. So then the AI will actually try to select the word east and provide that as an answer. So this is how it works. And then coming to output generation, fine tuning it. So users actually can adjust the output based upon the temperature and top case sampling. So that I will also tell how that works. Basically, the lower temperatures, which actually will actually be giving more deterministic or uh, more factual data. When the temperatures are set to high, it will be actually something futuristic, creative, uh, which is far from the reality. Okay. And then top case sampling is like it is just the limiting of the words that we are trying to choose. Okay, the most probable words, it will be like improving the relevance. If we try to bring down the limit of word choices, that is nothing but the top case sampling. Okay, so this is how the output is being generated in Gen AI. Um, So this inference and output generation actually happens step by step based upon the probability. Okay, internally with the architecture. Okay. So now we have seen what Gen AI is, what are its key components, how is it actually working. So this is about Gen AI, but then we need to also know what prompt engineering is. So prompt engineering is very vital. Basically, you're trying to use Gen AI tools, generative AI tools, and then uh, you need to know how to ask a question to get the desired output, right? So here the prompt engineering plays a very important role. Okay, so going ahead, we'll see what prompt engineering is. So basically, you can tell to frame a question. So how do you frame your question to interact with the Gen AI tool? So prompt engineering is a practice of designing and refining your input. Okay, so that you get the optimized response from the model. So it involves structuring of your prompt, it in any way, so such that the AI will understand, and then will try to understand what your intent is, what you're trying to expect, and then try to produce the accurate and relevant output for you. So, since the generative AI models such as ChatGPT and DALL-E do not think or understand like humans, they rely on the prompts basically. As I have told, these are narrow AI, so they cannot think like humans, but then they are just relying on the prompts, and the data that is fed from it, creates the patterns. So, what happens is, based upon the prompt you give, a well crafted prompt will actually guide you to have a high quality output. But then, if you give some vague prompt, like give me uh, some poem. So, what poem do you need? Do you need a happy poem? Do you need a poem describing about the nature? Do you want a poem describing about what? So, if you are more specific, it will create more relevant data outputs. Okay. So, when it is vague, it will actually create irrelevant or generic outputs. Okay. And then why this is actually important is, this is very crucial in improving the effectiveness and reliability. So basically, for you to rely on AI, if you're not giving correct prompt and telling that it is not giving correct output, and then you blame the AI that it is not giving correct output. But then the problem exists where your in your prompt, the way you're asking the question has a problem, right? So this is how it impacts. So here, improving AI response quality will actually is something which will actually impact by prompt engineering, also enhancing creativity and problem solving. Like AI can generate creative content, so based upon your input and your description, it will try to be more creative. So if you're trying to create an image with flying bikes, and then people with jets flying over the sea. So the more description, the more creative it becomes, right? So the more better output it would give. And then also, a good prompting helps in optimizing for specific use cases. So when you're actually trying to specify in what field are you trying to understand, like if you're asking questions from a law firm, it will try to uh, check for your like if your prompt is telling you are actually looking for something in the law firm, so it will actually help it to give you more specific data related to that. And then it will also help the prompts, like if you're in a customer service, so which kind of customer service, if it is a telecom, it would be a different way. And then if it is a support system for an e-commerce website, it would be different. So based on your prompt, it would be helping the AI to give more relevant data. And then um, uh, I would bring another example here, like reducing bias and errors. For this example is the if you're actually a particular word is being used in multiple cases, there will be an ambiguity, right? So when you're specifically telling the context, the prompt is telling. uh, what is that you are expecting. So the AI will try to inherit that particular context and will give you uh, more accurate data on the perspective that you need it. Okay, so for these, the important things are clear instructions actually, and the context and background on what you are expecting, and desired output format. So if you are actually trying to get some data, it will actually try to give it in a table format, and then you wanted it is in a file, CSV file. You can ask, you wanted that particular data in an CSV file, and then it would create a CSV file. You can download it and use it. Right, that's pretty simple. Else it would create a table. So again, you need to copy that table and then paste it somewhere else in the Excel. So this is actually trying to make it complex, right? So if you're specifically telling it your desired output format, it would help you get that. Okay, and then the constraints and examples. So you are actually trying to define boundaries. So this will actually help it to be specific and not to outbound. Okay, for example, if you take tell me about AI. So if you ask it to tell about AI, there is vast amount things to tell. And then do you need a length of data like a paragraph or 30 words or something in 200 words? You need to be specific. So that is a bad question. You can ask it this way, uh, being more specific. Explain artificial intelligence in simple terms, focusing in real time applications in healthcare, finance, and education. So you're telling how AI should be explained, how it should be in simple terms, and then what are the sectors: healthcare, finance, education. These are the things. So you're telling the prompt to be very specific there. Okay. So this is how a good prompt looks like. Okay. Then coming to the role of temperature and tokens in response generation. Basically, temperature does impact the randomness, basically, which will control the output of the input that whatever we are expecting. So when it comes to low temperatures, that is zero point 0.1 to zero point 0.3, AI will generate more deterministic and focused responses. So best for like summarization, coding, or factual queries. When it comes to high temperatures, which would be around zero point 0.7 or something, so here, what happens is AI will try to generate more diverse and creative things. So it will be like something like futuristic. So when you wanted to generate something like something that is exploratory, right? You don't know it would happen or something futuristic. So then it would help. And then coming to tokens. So limiting the response length. So this will actually help the prompt be more specific. We'll define the length of AI's response so that so many number of words you wanted. So it would give that much number of words only. So being specific to achieve your task. So higher token are used for detailed explanations, and then when you need short and crisp of a particular topic, you can use lower token limits. Okay, so this is how the prompt engineering works. So in prompt engineering, we have different techniques. Okay, that is zero shot prompting, few shot prompting, chain of thought prompting, instruction based prompting. So when you say about zero shot prompting, so when you ask, like this is a prompt wherein like you'll ask the AI to generate a response without providing any examples or prior context. The AI completely relies on the pre-trained knowledge that it has, and then it will try to infer the correct response. So how this works actually, the model will generate uh, specific to whatever question you have asked only. So you haven't provided any details. So, and it does not receive any examples also to guide you how the response should be. It will be like, what is the capital of France? So it is like you did not give any example or something. So it will tell the capital of France is Paris based on the data it has trained. When it is few shot, basically you are telling the AI model some examples. So I have a couple of examples, and then you are trying to generate the response based upon the examples you have given. So what is your desired? This will help the AI understand the pattern and the structure of your output, what you're expecting. So basically, you will give 2 or 3 examples before making your actual request. And then AI will understand the format, tone it, and then based upon what logic it is, it will try to give the output. You can take an example of predicting the number. In aptitudes, we usually have this number wherein what comes next. You will be given examples and you will be asked for sure. Uh, that could be one example. Or you have translated from English to Spanish a couple of words and then try to ask a new word, how is it called in Spanish? So it will try to generate the output based upon that. So it will identify, okay, you are trying to give an English word and trying to ask for a Spanish word. It will identify that, and for the one that you are asking, it will recognize that pattern and give that particular output. And then coming to chain of thought. Okay, chain of thought prompting is like wherein like prompting encourages to break down through problem step by step. You're trying to solve it step by step. Okay, you are trying to reason it process by you will reach the conclusion after a couple of steps. uh, so in this method what we'll do is you are trying to improve the accuracy logically, especially for the complex problems. Like instead of providing just an answer, uh, a, like the AI is instructed to show the thought process, like how is it going. So this helps in solving the logical reasoning math problems and also complex decisions. So, for example, you give this: if a train travels 60 kilometers in an hour, and how long will it take to travel 80 kilometers? Think step by step. So, you are actually telling it to do step by step and solve this. So for it will think, okay, how is it being done? So if it is actually taking 1 hour for 60 kilometers, okay, find out how much it will take for 80 kilometers. And then how then for basically it will try to identify for 1 kilometer how much time it is taking, and then it will try to identify for 180 kilometers how much time it will take. Then it will output the total time it has taken. So that could be one example where it is trying to go step by step and you asked it to do it step by step. It will also give you how it has done that calculation. So when do we use this chain of thought? Like when you're working with logical or math problems, and then you want AI to explain how it is done, you use this chain thought process. So these does have limitations. Like sometimes it can lead to verbose answers. Like if a AI is not well trained, the reasoning will not be that great. It would be a flaw. There would be flaws in the explanations and all. Okay. Then coming to the last prompting, that is instruction based prompting. So this instruction based prompting will involve AI will give AI clear instructions, what it needs, specific needs, guide its output. So this technique will actually ensure the response actually follows the structure, a particular format, what you need, and meets your expectations. So here what happens is the prompt will explicitly state how the AI should respond, and also include the format, length, whatever output is required. So, for example, summarize the following article with three bullet points. So, you give a text data and then you're telling it to summarize. So, it will summarize. So, you're also telling it you need only just three bullet points. It will try to summarize in three bullet points and give it to you. Okay, this is how it is. So, this is used when you need a structured response and then a control over the response, whatever you need. Okay. And this can be also used for professionals, like when they wanted to try generate an email or something. So they wanted to create an email, right? So you will tell on what specific reason are you writing the email, what is the purpose, and what are you trying to convey. Everything you give it, and then it tries to generate the email for it. Okay. But then what are the this does have limitations. So the user should be capable of giving well defined instructions to get the desired outputs. So if the instructions are vague, the AI might misinterpret them and give wrong outputs. Okay. So to be short, the zero shot promptings can be used for quick answers. The few shot actually improves response and accuracy, providing examples. And then the chain of thought prompting enhances logical reasoning. Okay, and then instruction based prompting ensures structured and well defined outputs that are expected by the user. Okay, so this is how the prompt engineering works, the different techniques. Okay, so let me quickly go to the next one. So after a lot of talk, a small activity here. So I wanted you guys to let me know, out of these two images, the first one and the second one, which is image generated, like the AI generated by image, and which is clicked by a human, or if both are generated by AI. Uh, can I have some quick answers? So we have seen a lot of theory about how it is working, right? The Gen AI, the image generation, and all. Yes. Can I have some first one? Okay, Bhavya, both are generated. Okay. Keep the answers coming in. Okay. Yeah. Mahesh Mangli is correct. Yeah, I have got some good responses. Yes, option C is correct. The first one is actually a human clicked image, and then the second one is AI generated. Some people have told both are AI generated. Yes, so now the generative AIs are actually very good at generating images, right? That are very realistic. Okay, yeah. Just wanted to take a quick activity so that you don't doze off. Okay, yeah. So going ahead, so we have seen the Gen AI, the prompt engineering. Let's see some Gen AI tools that we have. Okay, so basically we have. So I would like, as I'm from IBM, I would like to introduce you to the Gen AI tools of IBM. Okay, so IBM Watson X. So it is actually the complete uh, suite of AI and data solutions designed for helping the enterprises build, deploy, manage AI models. Okay, so it provides AI powered tools for generative AI, data management, governance, and automation. So under these, we do have Watson X AI, Watson X Orchestrate, Watson X Data, Watson X Governance, Watson X Code Assistant. So let's see these tools in detail. Okay, so what is Watson X AI? So basically, Watson X AI is a generative AI machine learning studio where it actually helps in creating IBM's enterprise grade AI platform. It will actually enable to build, train, fine tune, deploy generative models and traditional machine learning models. Okay, so the key features of Watson X AI are the foundation models. So you can access fine tune and pre-trained models, and then prompt engineering, and then customization, okay, of the outputs that you need, and then AI for business. So it is actually designed for trusted, explainable, and scalable enterprises application. And then it is actually supported by hybrid and multi cloud support. So you can deploy these AI models there. So this is about Watson X AI. So coming to Watson X data. So here it is actually open data lake, basically AI powered automation tool that helps access to wide number of data. So when it comes to business, the business will actually have lot of data, right? So this will the Watsonx data will help to optimize the data platform. So being a data engineer, it is very helpful to automate and try to use these uh, AI assistants for the data pipelines that we build and all. So basically what happens is like it has open data structure. It will support multiple data formats. We can work with data across any cloud, on-premise environments, everywhere. And then it is also cost-effective querying. So you can reduce a lot of cost on querying, and then data visualization is actually easier using Watsonx data, where you don't need to sit and do everything. So access analyze data without moving it, so you can actually get it done there itself with Watsonx data. So when this is actually more advantageous because the future is unstructured data. So basically, until now, we have got a lot of structured data from different sources. But now the future is unstructured data. There is no structure, there is no format. You just get random data from random devices, IoT devices, and all, right? So that would be the future uh, of the data engineering, handling unstructured data completely, and then building the AI, artificial intelligence models there. And then coming to AI governance, this Watsonx governance. So basically, it is an end-to-end tool that will actually give the compliance things. Okay, so it will actually try to create um and security layer for all the data and then tasks that we have. So it will try to mitigate the risks whatever are actually happening, or it will try to shield the data and the tasks from the vulnerabilities. So that is what's the next governance. Then coming to what's the next orchestrate. Okay, so basically what's the next orchestrate is something like you will be able to build pipelines. So on what do you build? So you are actually trying to build workflows. So if a particular HR, for example, there is an HR and then he needs to transfer a candidate from one manager to another manager. So that is a kind of repetitive task. Whenever a new request comes, they need to do. If at all, they try to create a workflow. Uh, so what happens? They just trigger the pipeline, and then this happens automatically, and then this will also trigger emails for approvals. So approval is done automatically, and then the access is provided, and the candidate is transferred from one manager to other. And then if he needs to actually gain access to some resources, so he can directly gain access when the pipeline is triggered. Okay, so this is how uh, it actually works with orchestrate. So it is nothing but we are actually trying to like as the image here is actually an example wherein you will try to create multiple workflows for each repetitive task and then try to ask the assistant to trigger that particular tool. And then coming to what's the next, code assistant. So here the assistant is like something which will help you generate code. So what's in a code assistant is actually supporting multiple programming languages like Python, Java, SQL, and more. It also ensures the code flows best. And then, since being an internal tool, the data or the code is not breaching outside. So, it is an internal tool where you have internal projects being analyzed. You will try to so instead of it will actually make the developers life easy, right, by optimizing debugging the code. So you have a good reference wherein you will not spend hours of time spending to generate the code rather than spending on having the code generated for you for yourself in just few minutes. So coming to Gen AI industry use cases, so sales and marketing. So the sales, like we can boost the sales and marketing by creating a robust sales automation system. By embedding the Gen AI platform, you will be actually leveraging AI-driven content and then transcription, which will actually help the marketing teams to deliver more personalized experience and analyzing the customer feedback. So it would be when the customer is actually given an importance, so basically they are winning the game, right? So AI actually helps in boosting the sales there. And then control, when it comes to contract management, so managing and analyzing the data. So how do we do this is by leveraging the data lakehouse. So what's the next, data? So we try to automate a contact create. We are having a contract, so we will try to automate this contract creation, and then we try to get valuable insights, and then try to do have less manual intervention, so that no human being needs to go verify, do things. So we will actually try to enhance the procurement process so that the contract management is done easily. And when it comes to human resources, we can actually improve the HR operations and engagement, like by automating the outreach to potential candidates and scheduling and interviews. These all can be done by AI. Uh, by creating an optimized and well crafted job descriptions to attract qualified candidates. When the job descriptions are matching exactly with the candidates, they would be more attracted to apply. So by this, they will actually bridge the gap between the human being understanding the requirements and the qualifications of the candidate. And then another use case would be customer experience, like elevating customer support in healthcare, transform patient management, like if at all an AI assistant is used to organize all the data provided, like so that it will help the patient have quick answers, queries, so that they need not wait for the doctor to respond. Okay. And then when it comes to finance, like optimized transaction advisory software, so by enhancing the transaction advisory software by like combining millions of sorry, okay, yeah, so improving by identifying potential problems early and then making an informed decision. So this will have help us have optimize the transaction advisory software being more accurate. So these are a couple of use case in the Gen AI industry. Okay. So then coming to bias and ethical concerns. So what happens is we have while we are training the data, right? Generative AI models learn from vast data, right? But if we are trying to teach it, like providing it only some data, we are trying to create bias. And then ethical concerns also are there because of the deep fake and all. We are actually not knowing whether it is an um coming from a trusted source or not. And then coming to data privacy and security, like somehow the AI model don't know that it needs to protect, and then it might also provide the sensitive data, right? So there are cases like data might breach. And then model interoperability, so it means like basically all the Gen AI models are black boxes. Okay, so basically you don't know what internally is happening. So you just give an output, and then this output is coming, but you don't know what is actually happening. So this is another uh, like drawback, that you don't know what exactly is happening. You don't know, like you're not getting the explainability of what the AI model is doing. And then we also have limitations on Gen AI, that is, you are actually trying to lack creativity and originality. If you see GitHub, Microsoft GitHub Copilot, so what it is doing, you are trying to write, it will actually help us to write an email. So at some point of time, you will actually lose that creativity of writing your emails by your own. You're doing it, so it is improving the life, but also it will actually slowly, gradually decrease the creativity that we have. And then there will come a stage where you will not be able to identify, you will be in a hallucination where you will not be able to identify whether it is AI generated or it is coming from a trusted source. So such kind of limitations also um, do occur. So AI holds enormous potential, but then it also comes with ethical and privacy concerns here. And then, so this is a brief of the generative AI. And then I would also give you some reference documents um, wherein you will be able to go through more about the artificial intelligence and all. So I'll be sharing this with your faculty. I would quickly wanted to show you a quick demo. Sir, do we have time? A quick demo.
Yes, ma'am. 10 minutes is there. Yes.
Okay, yeah, sure, sir. So basically, I'll be providing these URLs, this Watson X. So when you go to this portfolio, you do have the different AI models here, the generative AI models. You can just go here. I'll try to do one. You like we do have 100 hours of free trial, so you can explore that. So I would go for sign up with Google. I think I'm not sharing that screen. Share. Okay, sorry. Like I was showing this screen actually. The portfolio here we do have what's the different AI models, artificial intelligence models. We do have free trails for them, so you can just click on that. And then so here you would have the documentation and then quick illustration of how it works. Okay. And then I'll okay, sign up for Google. Start free trial. I already have one. So this is actually open for everyone. So you'll be able to use it. Okay, let me use it here. Okay. So next. So basically, have we heard right? So everything has a documentation on whatever we have seen. So you can go and explore there. So here how it spins up, and then you can go here, what's next, and then get started. And if you wanted to learn more about artificial intelligence, so I've given provided the artificial intelligence, and then you can go through the foundation models that are there available. So for your future reference, okay, okay. Here the Watson X is pinned up. So now this is the prompt. Like this is actually very similar to ChatGPT that you would see. You can actually build workflows here. You can actually write code, write an email to professor to extend the assignment submission date. Okay, that is what people students ask for, but for a good reason. Okay, due to campus hiring going on. See, if you see, I have some grammatical mistakes as well, right? But then we'll see if it will be able to. Yes, it is actually able to identify due to current high. Like it is trying to correct the grammatical mistakes, whatever it has, and it will try to provide. Okay, request reason for the request, reason for extension. It is actually giving how your email should be like. You can actually fine tune as we have seen the prompt engineering, like to optimize more better way. So like this we do have this orchestrate for building workflows, and then code assistant to generate the different codes that you need. Like it supports Python, SQL, Java, and all. So yeah, so that is about the Gen AI tools that we have in IBM. So going back to PPT, so I've provided all the links, so I'll be sharing them as well. If so, any questions, I'm open to the questions. Yeah.
Dear participants, if you have any queries, you can post it now.
Uh, Hope you understood. Uh, Future of AI jobs. Okay, apart from prompt engineers, like it would be like um, AI will not replace humans. I have also put my quotation actually in the next slide, like saying AIs will not replace human beings. There will be still jobs. Okay, so you need to train the AI models, right? Who is gonna train? Who is gonna identify? You're generating a code. So NVIDIA told we are trying to actually use the code generation tools, but then there needs to be someone who will actually correct that, whether verify whether that uh, that is generating is correct or not, right? But it will actually try to have for companies, right? If it is actually getting the work done by 10 people, it would actually decrease the resources, bring down the resources to 5 people, 2 people. It can like the work done by n number of people can be brought down. So by that, it will actually help the enterprises, the businesses to work better, like optimize their costs and all. So it is not going to replace, but then it will actually bring in new jobs actually. So there is still a good scope there. Do IBM have its own foundational models? Yes, it do have. So yes, it is being tuned internally. So we do work on tuning that. We are actually using Granite model currently. That is the stable model here in IBM. Yeah.
Yes, any more questions, participants?
Hope you got some at least few knowledge, some knowledge, something that you didn't know in this. Can you explain how Watsonx leverages found? Okay, fine tuning and enterprise applications. Okay, you want me to explain what I didn't get your thing. How like how it is using? Basically, when it says fine tuning, right? Enterprise application. So basically, in HR we have automated the task, the HR tasks we are automating, and then we have something like contract documents. So basically, we are using these models to summarize the contracts between the businesses that happen. So we are actually using this Gen AI so that we are actually uh, optimizing our work, the time spent by the developers. So even GitHub Copilot, if you see that, so we are actually using all these to actually decrease the amount of time we are working, spending on doing our daily work to very less. So whatever we are doing manually are being automated. The contract documents or the if at all we are having a recording, a KT knowledge transfer recording is there. There is a transcript. Your manager needs to know what has happened in that particular session. So he just goes and takes the transcript, give it to the tool, and then tries to get what actually is being explained. He gets the summarization and then he takes it over. So that is how we are implementing, like in multiple levels that is being used, and then how the fine tuning is done. So we have separate teams working on improving the accuracy, improving and then fine tuning the models. So as I've shown, though, I have also given URL for the foundational models. There, each model and then what has improved for the next model is also given. So you can go through that documentation there. Yeah.
Yes, friends, is there any more questions? Okay, so yeah, thank you. So if there is no more questions, we can conclude the session. Thank you, Ms. Dikshita, for your valuable time. And really, it is a wonderful session. Like we came to know about that tools also and the Gen AI, how to prompt, how not to. We came across so many things. I think the participants have also got some insights into the Gen AI. Thank you so much. Thank you, Dikshita. And I thank all the participants for your presence and your patience in listening that session. Thank you all. Now the feedback link will be shared and you please fill it before 8:30. Thank you, ma'am. Thank you,
Yeah.
everyone.
Thank you, everyone. Yeah.